Spring water undergoes a long journey before bubbling to the surface. Rainwater soaks into the earth, where it is filtered to become pure, clear water, which sustains life. The earth is like a giant filter. Since ancient times, filtration techniques have been used in both daily life and industry. KURITA Machinery manufacturing company's fully automatic filter presses achieve more perfect separation of solids and liquids by utilizing advanced microtechnology. The process of separating a liquid from the solid particles it contains is called solid-liquid separation. Such solid-liquid mixtures are commonly known as slurry. Slurry separation is generally carried out by sedimentation concentration, filtration, compression, centrifugal separation, or air-blow dehydration. Solids and liquids have different specific gravities. If slurry is left undisturbed, solid particles with a higher specific gravity will settle at the bottom of the liquid. This is called sedimentation concentration. Conversely, if the solid particles have a lower specific gravity, they will float to the top. This is called flotation separation. The solid and liquid of a slurry can be separated by passing the slurry through cloth, paper, wire mesh, or another porous material through which the liquid will pass, but the solid will not. This is called filtration. The porous material used is called a filter medium. The liquid which passes through the filter medium is called a filtrate, and the solid matter held back on the medium is called cake. For the liquid to pass through the filter medium, force must be exerted on the slurry. There are 3 types of filtration methods, classified according to the type of force used. In gravity separation, separation is carried out using only gravity. In vacuum filtration, similar to a coffee siphon, suction is used to separate the slurry. In pressure filtration, slurry is subjected to pressure to pass it through a filter medium and separate the solid from the liquid. The cake can generally be described as a porous mass of non-fluid solid particles containing liquid. Compressing the cake toward the filter medium squeezes some of the remaining liquid out through the filter medium, making the cake drier. This process is called compression. In centrifugal separation, slurry is acted upon by centrifugal force, which causes solid particles with a higher specific gravity to separate and move outwards. Another method is air-blow dehydration, in which air is blown over the cake surface to expel residual liquid through the filter medium. Among the solid-liquid separation methods just described, pressure filtration offers important advantages. First, it is safe and reliable. It also requires less space and offers greater effectiveness. Innovative variations on this technology are employed by KURITA's fully automatic filter presses. Since its establishment in 1930, KURITA has specialized in the manufacture of filter presses, contributing to both industry and society through reliable technology and a complete line of products from manually operated to fully automatic models. Let's look at an example. At this water purification plant, a KURITA fully automatic filter press is used for the filtration and compression of sludge from wastewater treatment. The filter press operates fully automatically, 24 hours a day. The filter press used here is the model HJMF2BW, which has 86 chambers with 1 meter square plates and a total filter area of about 140 square meters. After the slurry is concentrated in the concentration tank, it is temporarily sent to the slurry storage tank. The slurry is filtered and compressed in the filter press, separating it into filtrate and cake. The separated cake is then carried on a belt conveyor to the cake hopper for temporary storage until it is carried out of the plant. The filter press automatically performs filtration, compression, and cake discharge. Let's look at the process flow. First, slurry from the storage tank is pumped into the filter press. Inside the filter chamber, the slurry is filtered through filter cloths, with the solids remaining as cake in the chamber. The clear filtrate is discharged from the filter press. The filtrate from the filter press is characterized by exceptional clarity. Filtration is controlled according to time, pressure, or the volume of filtrate. The next step in the process is compression dehydration. In the compression process, the compression membrane is inflated by applying air or water pressure to the back of the membrane, reducing the filter chamber's volume and forcing the remaining liquid out of the cake. At this plant, the cake is compressed for about 1 hour with a water pressure as high as 15 kilograms force per square centimeter. The compression dehydration step is time controlled. At the end of the specified time, any residual water inside the membrane is drained. At the same time, slurry remaining in the center port is blown out of the filter press. Next, the cake is discharged. First, the drip pan opens, and a conveyor under the filter press begins to move. At the same time, a hydraulic pump opens the movable head which had tightened the filter plates. The filter plate carriers then open the filter chambers one at a time, discharging the cake. When necessary, a filter cloth vibrator shakes the filter cloths to dislodge any remaining cake. Cake discharge takes 7 to 9 seconds per chamber. With a moisture content of about 60%, the dehydrated cake is hard and flat and easy to handle. After cake discharge, the filter plate carriers return to their original positions. The filter plates are refastened, and the next cycle of the filtration process begins. In this way, the operation is automatically carried out in cycles. The filter cloths are washed to prevent clogging so that they maintain their filtering performance. The filter cloths can be automatically washed after a specified number of cycles depending on the usage conditions. In the filter cloth washing process, first the movable plate opens as when discharging cake. Next, the filter plate carriers and the filter cloth washing unit begin to move, and the filter cloth washing pump begins to operate. After sensors confirm that the nozzles have been positioned in the center of the open filter chamber, the nozzles are lowered. A sensor in the washing unit detects the filter cloth surface, and washing fluid is sprayed at a high pressure of 40 kilograms force per square centimeter. After washing one chamber, the filter plate moves to open the next chamber. In this way, the filter cloths are washed one chamber at a time. Washing at a high pressure of 40 kilograms force per square centimeter prevents the filter cloths from becoming clogged and ensures complete filtration and cake removal. Designed specifically for solid-liquid separation, KURITA's fully automatic filter presses are widely used at water purification plants, at sewage treatment plants, to treat industrial waste sludge, and for the production processes of chemicals, food products, pharmaceuticals, and many other products. KURITA manufactures numerous different models for a wide range of applications: to obtain a particular filtrate or cake, to obtain both a filtrate and cake, or to dispose of both. In 1960, KURITA developed the Model RF, the world's first fully automatic filter press. It was the first of many filter presses that KURITA has since developed and attracted wide attention throughout the manufacturing industry. It is a recessed plate, non-compression type with a center feed system. It is used for high-pressure filtration or high-temperature slurry, such as in edible oil refining. In 1969, the MF was developed by installing a natural rubber compression membrane on the filter plates of the RF, which was simply a pressure filter press, and adding a compression function, thus achieving a fully automatic compression filter press that produced much drier cake. With a non-compression type filter press, to reduce the cake's moisture content, filtration had to be performed at high pressure for an extended period. But with the MF compression type filter press, cake with an even lower moisture content can be obtained by filtering at low pressure for a short time and then compressing at high pressure. The shorter cycle time makes it possible to increase the dehydration speed. Because the MF's compression membrane has a one-piece structure, it lasts much longer than a separate type membrane and has gained wide acceptance. With a fixed filter cloth system, the filter plates must be moved one after another for cake discharge or cloth washing. On the Model UF, however, all of the filter plates are opened simultaneously at uniform intervals, and the filter cloths move up and down for cake discharge and filter cloth washing. The UF is a top feed compression type filter press. To discharge the cake, the filter cloths for each of the filter chambers are rolled by rollers located underneath the chambers, enabling easy discharge even of thin cake. The Model PF has a unique filter cloth suspension device for its fixed filter cloths. Similar to the UF, it is a top feed type. By employing a separable feed port protector, the filter cloths can be vibrated over their whole filtering area, enabling complete cake removal. This top feed filter press is capable of high pressure compression up to 25 kilograms force per square centimeter. In contrast to the PF's top feed system, the Model BF has a bottom feed system in which slurry is fed from the bottom of the chambers. When discharging the cake, the entire filtering area of the filter cloths is vibrated to ensure complete cake discharge. The BF is capable of high pressure compression of up to 25 kilograms force per square centimeter. Developed in 1987, the Model FM filter press features a completely new design concept that employs a filter frame in place of conventional filter plates. While previous filter presses used filter plates as walls separating the individual filter chambers, in the FM, the filter chambers are formed by the compression membrane and the filter cloths. By eliminating the filter plates, the press's overall length has been reduced by about 30% and its weight by about 50%. The Model MF3A uses state-of-the-art technology to control the filter plates, compression plates, and other components of the Model MF for the ultimate in ease of maintenance and operation. it has the same basic construction as the MF. Countless different types of slurry can be processed using filter presses. The operating conditions vary depending on the type of slurry. KURITA produces a wide selection of filter plates and compression membranes to meet specific customer needs. KURITA's polypropylene filter plates are only about 1/4 the weight of cast iron filter plates. They also feature excellent chemical resistance and durability. KURITA's cast iron filter plates are ideal for very high temperature slurry and are the perfect choice for the refining of vegetable, animal, or mineral oils. The compression membrane for the MF filter press features a unique one-piece structure. No bolts or other hardware are required for installation, ensuring a consistently long life. KURITA makes compression membranes of natural rubber as well as various types of synthetic rubber. Polypropylene compression membranes can be used in fields requiring greater chemical resistance, heat resistance, and oil resistance than rubber membranes provide, greatly expanding the range of applications for compression filter presses. As you have just seen, filter presses are used for solid liquid separation in wastewater treatment and for production processes in an extremely wide range of fields. Thus, they must be able to process many different types of slurry. To design the ideal filter press for each specific type of slurry, KURITA utilizes its many years of experience and a wealth of accumulated data from solid liquid separation and filtration experiments. Customers are requested to provide samples of the actual slurry they will be handling, so that KURITA can perform filtration, compression, and cake washing experiments in order to design the ideal filter press for that specific application. Working from this design, KURITA prepares specifications and drawings based on customer preferences, and then manufactures the filter presses and peripheral equipment according to the exact specifications. In a totally integrated operation, KURITA carries out everything from planning and design to final inspection, calling upon a wealth of accumulated experience and know-how. Every effort is made to ensure that the filter presses KURITA manufactures are of the highest quality, and also that they are delivered exactly on schedule. KURITA's filter presses provide quick and effective solid liquid separation. Advanced filtration technology is vitally important to the creation of a better life and to protection of the global environment. As a specialized filter press manufacturer, KURITA will continue to contribute to industrial and social progress through reliable technology. Introducing a new age of filtration technology from KURITA.